Hello everyone. In this lecture video, I will demonstrate how to solve problems involving maxima and minima. Okay? So, differential calculus finds a lot of applications in solving problems that involve optimization, from engineering, physical and social sciences, to business and even in economics. Okay, for example, if you remember the honeycomb conjecture, ano ba itong honeycomb conjecture na ito? So, if you're familiar with a honeycomb, alam mo naman siguro kung ano itsura ng honeycomb na paborito ni Winnie the Pooh. Okay, so yung pinaglalagyan ng honey ng mga honeybees, honeycomb yon. So kung iyong napansin, yung shape ng honeycomb, they are all hexagonal. Okay? So bakit kaya hexagon yun? That has something to do with economics. Okay? So, to accommodate the maximum amount of honey, the maximum volume of honey, and the minimum amount of materials required for building that honeycomb, kinakailangan hexagonal ang shape ng mga butas doon sa honeycomb. Okay? So, paano nalaman ng mga honeybees na kinakailangang hexagon pala itong mga butas sa honeycomb? Nag-aral ba sila ng calculus? Hindi. Tinuruan lang sila ni Jollibee. Joke lang. So, this honeycomb conjecture has been proven by mathematicians. However, it has been studied thousands of years ago pa. Okay. Now, for other examples, halimbawa, binigyan ka ng material sa paggawa ng isang storage bin or storage box. So, gusto mong ma-maximize yung volume. Kung gagawa ka ng storage box, kailangan mag-come up ka sa pinakamalaking volume using the smallest amount of material. So, that is an example of optimization problem. Okay? Now, kung gagawa ka rin ng isang material, halimbawa, gusto mong ma-minimize yung cost sa paggawa ng isang bagay. Okay? So that is another example of optimization problem. That is why differential calculus also finds applications in business. Because if you are doing business, of course, you want to maximize the profit. However, you want to minimize the cost that you'll be spending for that particular business. Okay? So in this lecture video, I will be solving several example problems to demonstrate to you how to solve optimization problems. Okay? The intended audience are first-year engineering students, yung mga students ko sa calculus. However, this might also be useful for those who are preparing for the board exam. However, yung mga shortcut techniques na gumagamit ng calculator, I will be demonstrating that in another video. Okay? So if you're ready, let's get started. Okay, so before I demonstrate how to solve applied max-min problems, let me first discuss some relevant concepts about the maximum and minimum points in a function. Okay? So, ito muna yung concept behind the problem-solving approach na i-discuss ko later. Okay, so for example, we are given a certain arbitrary function f of x. Okay? At itong f of x na ito, ang graph, ganito yung itsura niya. Halimbawa lang, kaya nga sinabi natin, arbitrary function. Okay, so anong meron dito sa graph na ito? Of course, itong graph, this will go on downwards indefinitely, and this will go on upwards indefinitely. Walang katapusan yan. Okay, so pero mapapansin natin sa point na ito, at saka dito, meron tayong maximum point na tinatawag. At this point naman, meron tayong tinatawag na minimum point. Okay, so if we will consider this function in an open interval, meaning kung open ang interval na yan, ito dire-diretso pababa, at ito naman, dire-diretso pataas. Okay? Ito ay tinatawag nating local maximum at ito naman ay tinatawag na local minimum. Sir, bakit po local? Kasi po, if this goes downward indefinitely, I am sure there will be a point in the graph that is even lower than this. Kaya ang tawag lang natin sa kanya, local minimum. Okay? And this is a local maximum because if this part of the graph goes upward indefinitely, we are pretty sure that there are many points higher than this. That's why this is just a local maximum. However, in real life, when we solve problems, we consider the function in a certain closed interval. Ang ibig sabihin nun, itong graph na ito, hindi mo i-consider dire-diretso pababa at ito naman dire-diretso pataas. No, it's not like that. Kinakailangan, magseset tayo ng interval kung saan kukunan natin ang maximum, ang minimum value yung function. No? So, kung close ang interval, halimbawa, mula lang dito, no, sa x is equal to 0. Hanggang, for example, dito sa part na ito. O, lagyan natin ng ballpen. No? Okay. Okay, halimbawa, palitan natin ang kulay. Gawin natin violet para medyo malandi. Ayan. Hanggang dito. Okay. So, if we will consider the function in the interval from 0 up to this value of x, then this maximum point is the highest point in that interval. And we say that this is the absolute maximum. Okay? And likewise, this point from this or within this interval, this is the lowest point. No? Again, only within this interval. That's why we call this the absolute minimum. So, yan tinatawag natin na extremes. No? Absolute maximum at saka absolute minimum. Sometimes tinatawag din sila na global maxima at saka global minima. Okay. Now, whether the maximum or the minimum point is local or global, ano ang common sa kanila? Okay? So, kung ating lalagyan ng, halimbawa, tangent line dito. Pen. Saan na yung pen? Maglagay tayo dito ng tangent line sa point na ito. Okay. So, kung ano man ang slope ng tangent line na ito, at this point, kung ito ang point of tangency, remember, saan equal yon? Equal siya sa first derivative, right? So, halimbawa, andito ang tangent line. Ano itsura ng tangent line dito? At this point, the tangent line looks like, halimbawa, papaganyan siya. How about at this point? How about at the maximum point? Ano na ngayon yung itsura ng tangent line dito? Okay? So, the tangent line looks like horizontal, no? And if we will consider the minimum point, ano itsura ng tangent line at the minimum point? It is also horizontal. So, whether the point is a minimum or a maximum point, the tangent line is always horizontal, no? So, dito na ngayon papasok yung kahalagahan ng mga concepts na natutunan natin before, no? So, let us recall that the slope of the tangent line, kung ito ay tangent line, saan equal ang slope niya? That is equal to the first derivative of the function. Halimbawa, kung ito ang point of tangency, kung ano man ang first derivative dito ng function, yun na yung slope ng tangent line. So, since the tangent line is horizontal, then whatever the slope of the tangent line is, then it must be equal to the first derivative. Okay? But recall also that what is the slope of a horizontal line? Kung horizontal ang line, ang slope niyan ay 0. So, that means that the horizontal lines, no, kung ang slope nila ay 0, ang first derivative ng function sa maximum at sa minimum point, that means yun ay 0. Yes. Okay? So that's the important concept that we need to consider when we will be solving maximum and minimum problems. We should always remember that at the maximum point or at the minimum point, the first derivative of the function is always 0. Why? Because at these points, maximum and minimum points, the tangent line is always horizontal. And remember that a horizontal line always has a slope of 0. Okay? So, tatandaan natin ha, sa maximum point and even here, at the minimum point, the first derivative of the function is always 0. Okay? Now, when we are solving problems, darating ang time, makaka-encounter ka ng cases kung saan dalawa yung value ng x na makukuha mo. Halimbawa, itong value ng x dito at saka yung value ng x doon. So, kung dalawa ang value ng x, paano mo malalaman kung alin doon sa dalawa ang magbibigay sa'yo ng maximum at saka minimum points? Okay? Dito na ngayon papasok yung kahalagahan naman ng second derivative. No? Okay, at the maximum point, the second derivative of the function is always negative. No? Negative po ang second derivative dito. Samantalang sa minimum point, ang second derivative ng function ay laging positive. Okay? So, kung dalawa yung nakukuha mong values, ang tawag natin sa kanila critical values, yung value ng x. So, halimbawa, ang first derivative, ini-equate mo na sa 0. May nakuha kang value ng x. So, ang tawag doon sa mga values ng x na iyon ay critical values. No? So, paano mo malalaman again kung alin dun sa dalawang critical values ang magbibigay ng maximum at saka minimum? Gagamit ka ng second derivative. Again, at the maximum point, dapat ang second derivative negative. No? And at the minimum point, ang second derivative naman ay positive. Okay? So, another important part of the graph is what we call the point of inflection. Ano naman ang meron sa point of inflection? This is a part in the graph of the function where its concavity changes. Ano ang ibig sabihin nito? Doon sa point of inflection, nagbabago ang concavity ng graph. Halimbawa, kung ito ang point of inflection ng graph na ito, then from this hanggang doon, siya ay concaving downward. Samantalang from here onwards, siya naman ay concaving upwards. Okay. Now, minsan ipapahanap sa problem ang point of inflection. So, paano natin siya hahanapin? So, what is the important thing that we need to consider about the point of inflection here? The second derivative is always 0. Okay? So, remember that at the point of inflection, the second derivative of the function is always 0. Okay? So, before we begin solving problems, let us have a recap. No? Again, at the maximum and the minimum points of a function, ano lagi ang rule? Yes, the first derivative is always 0. But at the maximum point, the second derivative is negative, while at the minimum point here, the second derivative is always positive. And another important point is the point of inflection where the concavity of the graph changes. And the important thing that we need to consider is that at the point of inflection, the second derivative is always 0. Okay? So, if you understand this well, then you are ready to solve maximum and minimum problems or yung tinatawag natin na optimization problems. Okay? Okay, now let us solve the first problem for this lecture video. So the first problem, medyo mathematical pa siya, ano? Hindi pa siya yung talagang application. Okay? So here's the problem. Given the function y is equal to x cubed minus 9x squared plus 15x minus 3. So this is a cubic function. Ano yung gusto nating malaman dito? So determine the following. A, the maximum point. B, the minimum point. And letter C, we want to find the point of inflection. Okay? So let us now solve the problem. So for letters A and B, kailangan natin ng maximum at saka ng minimum point. So alam naman natin na sa maximum and minimum points ng isang function, ano ang nangyayari? Mathematically, at the maximum and the minimum points of a function, what do we remember? Yes, we remember that the first derivative of the function, y prime, is always 0. And because of that, we will get immediately the expression for y prime. No? Kuhanan natin yung first derivative. No? Ano ang derivative ng unang term? That's 3x squared minus, ano yung derivative ng second term? 2 times 9 is 18. And then, ma-minus ng 1 ang numerator. So, 18x. And then, plus, the derivative of 15x is 15. Okay, so we have 3x squared minus 18x plus 15. And then, since at the maximum and the minimum points, y prime is 0, then we will equate this to 0. Ano? So, i-equate mo lang yan sa 0. No? Pag in-equate mo sa 0, you can now solve for x. So, since this is quadratic, you can get two values of x. Okay? So, kung tinatamad kang mag-factor, mag-calcu ka. No? Pero madali lang naman to. So, all terms are divisible by 3. Right? So, let us simplify this expression first. Dividing both sides of this equation by 3, we get x squared minus 6x plus 5. No? At yan, yung simplified expression na ito, yan ang iyong ifa-factor ngayon. So, what are the factors of 5? Positive 5 that will give us a sum of negative 6. So, that will be negative 1 and negative 5. So, the factors are x minus 1 and x minus 5. Okay? Now, if we solve for the values of x, of course, we'll get positive 1 and positive 5. Okay? So, mayroon tayong makukuhang dalawang values ng x, 1 at saka 5. Now, ano ang tawag dito sa dalawang values na ito? Okay? Kagaya ng nabanggit ko kanina, these values of x that we get when we equate the first derivative to 0 are what we call the critical numbers. Ano? Critical numbers po ang tawag dyan. Kanina yata nabanggit ko critical values. I'm sorry. It should be critical numbers. Okay, now, sir, alin dyan ngayon ang maximum at minimum? Sir, 5 is greater than 1. So, baka yung 5 ang maximum at saka yung 1 naman ang minimum. Tama ba yon? Mali. No. Okay, because the maximum and minimum values refer to the values of the function, which is represented by the value of y, not the value of x. So, ang gagawin natin, aalamin natin yung values ng y, hindi x. So, paano yun? Sir, kung dalawa yan, paano ko malalaman kung alin ang maximum at saka minimum? So, kanina, nabanggit ko na sa previous slide, we can use the second derivative test, no? To determine which of these two will give us a maximum and a minimum value. Okay, so kunin natin yung second derivative. Ano? So this is the first derivative. We differentiate with respect to x to get the second derivative y prime. So y double prime. So y double prime is 2 times 3, that's 6. So 6x minus 18. Okay. So ito na ngayon ang ating second derivative. 6x minus 18. So, anong gagawin natin? Ite-test natin parehas. No? So, pag kinuha natin ang second derivative kapag ang x ay 1, ito yon, y double prime of 1. So, that will be 6 times 1 is 6 minus 18 is negative 12. Okay. So, kung ang nakuha natin ay negative, ano yan? Maximum or minimum? Kung natatandaan yung discussion kanina. Okay. So, if you get a y double prime of negative, yun ang maximum point. O yun yung values ng x or value ng x na magbibigay sa'yo ng maximum point. So, dapat pag tinest natin itong 5 at sinubstitute natin sa second derivative, dapat mag-positive yan. Kasi natural, kung dalawa yan, yung isa maximum, yung isa naman minimum. Ano? So, let's test x2. No? The value of y double prime will be, so, 6 times 5 is 30 minus 18. Okay, so 30 minus 18 is 12. Positive, no? This is a positive second derivative. That is why this value of x, which is 5, will give us the minimum value of the function. No? Okay. So, ano na ngayon yung value nung, ano na ngayon yung point? Kasi point ang hinahanap, hindi lang naman critical numbers. So, madali lang yan. Kung point ang hinahanap, you get the value of y, no? When x is 1. And for the other point, you get the value of y when x is 5. Okay? So, gawin natin yan dun sa sunod na slide. Ano? Okay. So, i-copy paste ko lang ang given. This is the given function. And these are the critical numbers that we're able to solve. 1 and 5. No? So, yung 1 ang magbibigay ng maximum at yung 5 ang magbibigay naman ng minimum point sa atin. So, when x is equal to 1, what is the value of y? So, you solve for y1. Now, substitute mo lang dito yung 1. No? So, magiging 1 cubed minus 9 times 1 squared plus 15y. Or 15 times 1 minus 3. No? So, yan na yung value ng y1 mo. Pag sinolve mo yan, ang makukuha nating sagot is 4. Okay. So, now, we will have a point. 1 and 4. Yan na yung point natin ngayon. Na remember, anong point ito base sa value ng second derivative? since ang second derivative natin ay negative kanina, itong point na ito ay maximum, no? Maximum point yan. Okay? Now, how about the value of y when x is equal to 5? So, we again substitute 5 in the expression for y, no? So, that becomes 5 cubed minus 9 times 5 squared plus 15 times 5 minus 3. Okay. So, ito na ngayon yung susolvin mo, no? So, if you get a calculator and evaluate this expression, the value of y is negative 28. So, now we are able to obtain a point 5, negative 28. So, obviously, ang minimum dito ay ito kasi negative 28. At ito ang maximum, which is positive 4. Why? Because 4 is greater than negative 28. Remember, the maximum and minimum values of the function refer to values of y, not the values of x. So, kanina sabi natin yung 1 ang magbibigay ng maximum at yung 5 ang magbibigay ng minimum, no? Nung ginamitan natin ang second derivative test. Okay? Pero actually, kahit hindi ka na mag-second derivative test, no? After obtaining the critical numbers 1 and 5, you substitute them directly, no, to the function, no? And whichever will give you a greater value of y, that of course is the maximum, kagaya nito, at yung magbibigay naman ng mas maliit na value ng y, yun ang minimum. Kasi dalawa lang sila eh. So yung isa maximum, natural yung matitira, minimum. Naintindihan po ba? Okay. So we are now able to obtain the maximum and the minimum points of this particular function. Now what is the next question? The next question is to solve for the point of inflection. Okay. So ano nga ulit ang natatandaan nating concept about the point of inflection? Remember that at the point of inflection, POI, the second derivative of the function is always 0. Okay? Y double prime is 0. And nakuha na natin kanina yung y double prime na yan. That's 6x minus 18. So, copy-paste lang natin yung second derivative na na-obtain natin kanina. And then, we equate it to 0. Ayan, ka-equate na siya sa 0. And then, finally, we will solve for x. No? So, to solve for x, divide both sides by 18. O by 6 rather. So, 18, pag nilipat mo sa kabila, divided by 6, we will get a value of x equal to 3. Okay? Solving for x, the value of x is 3. Okay. So, yun na yung x natin. Ano naman ulit yung y? Kasi kailangan natin ay point eh. So, hindi lang x yun. Kinakailangan yung x, may kasamang y. So, kagaya ng ginawa natin kanina, if we want to get the value of y, then we substitute x equals 3 into the function. No? So, solving for y when x is equal to 3, y of 3 is equal to 3 cubed minus 9 times 3 squared plus 15 times 3 minus 3. No? So, kung hindi mo ma-mental math, again, pwede kang mag-calcu. No? Pag ginamit mo ang calcu, makukuha mo yung value ng y of 3, which is equal to negative 12. Okay. So, that means that the point of inflection is 3, negative 12. Okay? So, this is now the point of inflection. So, now we're able to solve the problem. We got the maximum, the minimum points, and finally, the point of inflection. Again, ano nga po ang nangyayari sa point of inflection? At the point of inflection, nagbabago ang concavity ng graph. No? From opening downwards, magiging opening upward na siya. Or vice versa. Okay. Now, for you to fully appreciate this example, let us take a look at the actual graph of this function and look at these points kung nasaan itong maximum, minimum, at saka point of inflection na ating na-solve. So, this is the graph, the actual graph of the function. So, anong ginagamit ko na pang graph? Gumagamit ako ng GeoGebra, no, graphing calculator. Okay, so this is the actual graph, no? So, here, we have the maximum point, no? 1, 4. And here, we have 5, negative 28. Ito yung value ng x5. Yun namang y, 25, 26, 27, 28. Ayun. 5, negative 28. And here, we have the point of inflection at 3, negative 12. Okay? So, kapag nilagyan natin yan ng tangent line, anong itsura ng tangent line? Again, at the point of inflection, gamitan natin ito ng pen. So, violet yung color. Halimbawa, lalagyan ko siya ng tangent line. Ayun. So, horizontal yung tangent line mo doon. Dito naman, dapat, ay, mali. Charot. Pangit. Pangit, ayoko na. Comedy bigla tuloy yung lecture video ko. Ayoko na. Ang hirap magsulat sa screen. Sige, wag na lang. So, at the minimum point, dapat, ang tangent line mo, ganito rin ang itsura. Ano? Bakit kanina ang dali kong nagawa yung horizontal line na yun? Sige nga, isa pa. Yan. Push natin. Okay? So, that's it. Okay na po yan. Now, let's proceed to the next example. Okay, so now let us solve the second problem. Problem number 2. Okay, let me read the problem. What is the largest area? Or what is the area of the largest rectangle that can be inscribed in a semicircle of radius 5? Okay, so how do we solve a or unapplied max-min problem? No, so i-illustrate ko sa example na to kung paano. Kinakailangan sa simula, kung kinakailangan mong gumawa ng illustration, gawa ka ng illustration. Ano? So in this problem, pinakamalaki daw rectangle, ilalagay natin nakasya sa loob ng isang semicircle. So gawa ka lang ng semicircle, tapos sa loob nun, lagyan mo ng rectangle. Tapos yung semicircle, given ang radius niya, 5 cm. So gawa ka ng semicircle at sa loob nun, dapat may rectangle. No? So, ayan. So, this is the semicircle, kulay green siya, no? At ito naman yung iyong rectangle, kulay pink, no? Ganyan din ba yung na-imagine mo? So, kung hindi, mali yan, no? Okay. So, now, ito yung kailangan nating i-maximize, no? Yung area ng iyong rectangle. Okay, so para yan ay maximum natural, kinakailangan the rectangle touches the semicircle para siya ay maximum. Pero hindi natin alam ngayon yung length niya at saka yung kanyang width, no? At yun ang kailangan nating alamin para malaman natin yung maximum area niya. Okay? So, nakapag-drawing ka na, anong sunod mong gagawin? Lagay mo ngayon yung given. No, ang given dyan, 5 cm daw yung radius ng semicircle. So, ilagay mo. At lagyan mo ng value. So, yan na nga yung 5 cm na radius ng iyong semicircle. Now, sir, anong sunod? Labelan mo din yung hinahanap, no? Yung rectangle. No? Ano ba ang dimensions ng rectangle? Meron siyang length at saka meron siyang width. Okay. So, kung sa semicircle, doon ka nag-start sa gitna, might as well, doon ka mag-start para sa rectangle. So, mula sa gitna hanggang dito, hindi naman natin alam kung gaano. At yun ay kalahati ng kanyang length. No? So, kung hindi mo alam kung gaano kalaki yan, i-represent mo siya using a certain variable. For example, x ang gamitin mo. No? So, from the center to this point, to the edge of the rectangle, we represent it using x. At sigurado ako, from here, papunta doon sa kabilang side, that has also the same value. Kaya, x din siya. Ano? So, this time, meron na tayong length ng rectangle na 2x. No? So, ano naman yung kanyang width? Ito yung width niya. So, wag na x ang gamitin mo kasi nagamit na natin yung x. So, this time, y naman, halimbawa, yung gamitin natin. Okay? So, now we can express the area, no, of this rectangle. Okay? So, what is the next step? The next step is to formulate the working equation. No? Sir, ano naman po ang working equation? Simple lang. The working equation is the equation of the quantity that you want to maximize or to minimize. So, ayun, madali lang, ano? Hindi ka na maliligaw doon. Bakit? Kasi kung ano yung i-maximize or i-minimize, yun lang ang gagawan mo ng equation. Okay? So, balik tayo sa problem. Dito sa problem na ito, we want to maximize the area of the rectangle. So, ano ba ang area ng rectangle dito sa drawing na ginawa mo? So, that is 2x times y, and that's it. You now have your working equation, no? Now, what is the next step after obtaining the working equation? The next step is to express the working equation in terms of a single variable. No? So, ano ang ibig sabihin nun? Ibig sabihin lang nun, kung isang variable lang dapat ang matira, then it should only be x or y. No? Sir, anong gagawin natin para matira yung x or y? Papawiin ko na dito yung y? No. No? Mag-iisip ka ng paraan. No? So, dahil dyan, babalik ka sa drawing. No? Doon sa drawing, baka may makakuha ka pang isang equation. No? So, remember, may given na 5. Hindi pa natin yung nagagamit. And that is the radius of the semicircle. However, kapag ka yung radius na yun, dito natin inilagay, di ba? Makaka-form ka ng right triangle. Ito siya ngayon, no? Yung x, yung y, those are the legs of the right triangle, at itong radius ng semicircle ang hypotenuse ng right triangle mo, from which we can formulate another equation. Tama po ba? Okay. So ano yung bagong equation na ma-form natin? Eh, gamitan mo ng Pythagorean theorem, no? So applying Pythagorean theorem on this right triangle, we can have x squared plus y squared is equal to the square of the radius, which is 25. Okay. So, ayan, nagkaroon na tayo ngayon ng bagong equation. At yan ang tinatawag naman natin na auxiliary equation. Auxiliary, parang katulong, no? Auxiliary. Okay. Now, katulong na equation na pwede natin gamitin para ma-express ito in terms of x alone or y alone. Sir, anong ititira natin? X ba yan or y? Kahit alin, no? You can solve for x or for y, depending on whichever is more convenient. No? Okay. So, dahil mahilig tayong mag-solve for x, so dito, x muna yung itira natin. No? So here, we solve for y, no? So we can replace y here and we can get an expression for the area which is purely in terms of x. Okay, so ngayon, solve na natin yung y, no? Y is equal to, ayan, itong x squared ilipat mo doon, so 25 minus x squared and then get the square root. So you have the square root of 25 minus x squared and we substitute this y here. So we can get an expression for the area which is purely in terms of x. Okay. So ngayon, ito na yung area natin as a function of x. Okay? We now have a function, no? So, itong function na ito, dahil ito ay isang applied max-min problem, kinakailangan nating lagyan ng constraint yung values ng x. Bakit? Kasi kung titingnan mo ang drawing, itong x na ito yun eh, no? At itong x na ito, imposibleng mag-negative, no? Kasi yan ay side or length ng side ng rectangle. At wala namang sense kapag sinabi natin na ang rectangle ay negative ang side. Ano? Kaya, magsisimula tayo sa value ng x na 0. So, ibig sabihin nun, kung ang x ay 0, ibig sabihin nun, 0 ang area ng rectangle. Yes, no? Theoretically, that is possible. So, we call such rectangle as a degenerate rectangle kung saan yung side niya 0. But still, in theory, it exists. Okay. So, ngayon, ano naman ang upper limit ng ating domain x? No? So, ang upper limit niya, tingnan natin to. Ito yung radius ng semicircle mo. At itong x na ito, hindi pwedeng sumubra pa doon sa radius. Otherwise, yung rectangle mo nasa labas na ng semicircle. Kaya, ang upper or ang upper limit ng ating domain ay magiging 5. Now, so we now have the domain of this function 0 to 5. Ano nga ulit yung domain? These are the possible values of x. Okay, so mathematically naman pwede rin. Now, by considering that x is a side, of course, the side cannot be negative, so it must start with 0. No? So, ayun yung 0. Now, pag in-inspect mo ang equation na ito, mapapansin mo rin na, okay, we know that the term inside the square root cannot be negative. That is why this cannot be greater than 25. No? So, kaya kung hindi pwede na mag-negative ang term sa loob ng square root, dapat ang maximum value ng x ay 5. Para kung siya ay 5 times 5 is 25. 25 minus 25 is 0. Square root of 0 is 0. However, if your x here is greater than 5, now you will get here a term that is less than 0. Magne-negative siya. And that cannot be kasi may square root po tayo dito. Now, so kaya ito ang ating domain na makukuha mo mula sa drawing or if you analyze mathematically. Now, what is the next step? The next step is to get the first derivative. Remember, sa max-min problem, the first derivative is always 0. So, bago natin siya ma-equate sa 0, kinakailangan kunin mo muna yung first derivative. So, let us differentiate this function of x. And if you notice, this is a product. No? So this is your u, and this is our v. And since that is the derivative of a product, we use the product rule. U times the derivative of this plus the second times the derivative of the first. So isa-isahin po natin, ano? Okay. So the first, which is u, 2x, no? Times the derivative of the second. But this second term, gamitan natin ang pen, ay pwede nating ma-express as, diba ito, pwede kong isulat as 20, ayan, nahirapan na naman tayo, 25. Ayaw niya talaga. Dito na lang. So that's 25 minus x squared. Ayaw niya talaga. Ang pangit, raised to 1/2. Ayan. So, siguro okay na yun. Nakita niyo na kahit paano. No? So, we will differentiate this. No? Paano ba mag-differentiate nito? Power function yan. Ano? Ito yung u, ito yung n. So, itong exponent niya magiging multiplier muna. So, magiging 1/2. Ito siya ngayon. Times, kopyahin mo lang itong buong to. Pero yung exponent niya, ma-minusan mo ng 1. Kaya 1/2 minus 1 is negative 1/2. So, copy-paste mo to. No? At yung exponent, ma-minusan mo ng 1. Kaya magiging to the negative 1/2. Pero hindi pa tapos. No? Chain rule. No? Kasi yung loob ng square root, may function pa. Kaya kukunan mo ng function yung nasa loob ng square root. Ito. Derivative ng 25, 0. Derivative ng negative x squared is negative 2x. Okay, so this entire expression is just, no, the first part, u times the derivative of v plus, no, the second term times the derivative of the first. Okay, so copy-paste natin to. The derivative ng 2x is, of course, 2. So that's 2 times the square root of 25 minus x squared. Okay, so nakuha na natin ngayon ang first derivative. Anong sunod na gagawin? Of course, we can simplify it first, no? So itong 2 na ito, ayan, halimbawa, magka-cancel siya. Ayan. Magka-cancel yung 2. Tapos ito naman, since ang exponent niya ay negative, pwede nating ilagay sa ilalim yan, no? And in the denominator, it will be inside a square root. Okay? Tapos x times x, may matitirang x squared, negative 2. No? So sa taas, magkakaroon ka ng negative 2x squared at sa baba nun, may term na square root of 25 minus x squared. Ito na siya. No? Plus, copy-paste lang natin yung second term. Okay? So this is now the simplified form of the first derivative. Now, ano nang susunod natin gagawin? Remember that for the maximum and the minimum values of a function, the first derivative is always 0. Now, so i-equate mo lang ito sa 0. Okay? So in the next slide, i-equate natin ayan sa 0. Ayan. Ito na yung itsura niya. Okay? So this is the first derivative. And equate natin sa 0. Anong sunod natin gagawin? We can divide both sides by 2. If we divide both sides by 2, magka-cancel to. Ayan. And then after that, pwede mo na siyang ilipat sa kabilang side. Okay. So this term, ilipat mo siya sa kabila. At ang makukuha mo, ganito na siya. Ayan. So, anong sunod natin gagawin? We can multiply both sides by this denominator. No? So, pag minultiply mo both sides ng denominator, mawawala ito. No? And in effect, mawawala din yung square root dito sa kabilang side. No? So, if we multiply both sides by this term in the denominator, this will now vanish and the square root here will effectively be removed. No? So, ito na ngayon yung makukuha natin. Yan. 25x squared is equal to x squared. Tapos itong negative, ililipat mo sa kabila. So, magiging 2x squared is equal to 25. Yan. So, from which we can solve for the value of x. No? 2x squared is 25. Therefore, x is square root of 25, which is 5, divided by square root of 2. So, since square root yan, dalawa yung values, positive at saka negative. Okay, so of course, ang gagamitin natin is yung positive value ng x kasi yun ang magbibigay sa atin ng positive na area. Okay? So this is now the value of x, no, that will maximize the area of the rectangle. No? So ito na ngayon yung critical number natin, no? Again, what does this critical number represent? This is the value of x that will maximize the area of the rectangle. Okay, now since we know already the value of x, we can substitute it to the expression for the area. Diba ito yung area natin as a function of x. So, kapag isinubstitute ko yung x is equal to 5 over square root of 2 dito, ano makukuha ko? Yun na ngayon yung maximum value ng area. At yun yung hinahanap natin, which is the maximum area of the rectangle. So again, if I substitute x is equal to 5 over square root of 2 here in a of x, I will get the maximum area, a max. Okay? So, kunin na natin yan yung maximum area. 2 times x, which is 5 over square root of 2, times the square root of 25 minus x squared. So, ano ba yung x squared? That is 25 over 2. Okay? So, pag isinimplify mo ito sa calculator, 25 minus 25 over 2, that will give you 25 over 2 as well. Now, so square root ng 25 is 5 at may matitirang square root of 2 sa ilalim. No? So, ito na ngayon, i-rewrite natin. So, 2 times, 5 over square root of 2 times another 5 square root of 2. So, here we will get 25. No? Tapos ito, square root of 2 times square root of 2 is 2. And that 2 in the denominator will simply cancel kasi may 2 pa tayo dito. Na, okay, so ngayon, ano ang matitira? Ang matitira ay di 5 times 5, which is 25. At ang unit, square centimeters. Okay, so this is now the maximum area of the rectangle which we can put inside a semicircle whose radius is 5. Okay? So, madali lang, di ba? Okay. Actually, medyo matagal siyang isolve kasi may step-by-step procedure. Pero since may step-by-step procedure, hindi ka rin maliligaw. No? So, medyo matatagalan nga lang. However, kapag nasanay ka naman sa pag-solve ng problem, bibilis ka rin eventually. Okay? So, again, let us recall the problem. Ano nga yung radius? 5. Anong sagot? Pinakamalaking rectangle sa loob niya? 25 ang radius. Oh my God. So, what if pinaltan ko ang radius ng semicircle? Ginawa kong 10. Ano na ngayon ang pinakamalaking area ng rectangle na kasya sa loob niya? Kasi kanina 5, naging 25. So, kung ang radius ay papalitan ko ng 10, baka maging 100 yun. Kasi ito 5 squared, 25. Tama kaya yun? Yes. Actually, may shortcut tayo dyan. No? So, for this particular problem alone, no, the largest rectangle that can be inscribed in a semicircle is just the square of the radius. Ayan. So, if you ever encounter this problem again, hindi mo na siya isosolve mano-mano. No? May shortcut siya. I-square mo lang yung given radius, yun na yung maximum area ng rectangle na kasya sa loob ng semicircle. Diba? Isn't that amazing? Yes. Okay. So, after this, we will solve the next problem. Okay, so let us now let us solve problem number 3. Okay, so here's the problem. The sum of two numbers is 21, and then the product of one of the numbers by the square of the other is to be a maximum. So now what are the numbers? So number problem naman ito. No? So yung steps kagaya pa rin nung kanina. No? So dito hindi natin kinakailangan gumawa ng drawing. Now, we just translate the given worded expressions into mathematical expressions. So, of course, first we need to represent the numbers. For example, we represent the numbers as x and y. Okay? So, for example, the numbers are x and y. Halimbawa, yun ang ginamit mo na variables. So, anong sunod mong gagawin? The sum of two numbers is 21. So, the sum will of course be x plus y, and that x plus y is equal to 21. So, you write it down. That is one of your equations. And then, the product of one of the numbers by the square of the other is to be a maximum. So, we need a product. Which are we going to multiply? One of the numbers. For example, that is x. and then the square of the other. Okay, so we will multiply x with the square of y to get a certain product p. No? So that x times y squared is equal to a certain product p. So ito na ngayon yung ating equation. And that p, according to the problem, this p should be a maximum. So which are we going to maximize here? No? It's very clear that we want to maximize the product. So if we want to maximize the product, which of the two is our working equation? Is it the first one or the second one? Okay, that's the product. Yes, so that's the second one. This is our working equation, and this, of course, is our auxiliary equation. Now, looking at the working equation, we have two variables, x and y. Now, our next goal is again to express the working equation as a function of a single variable. Okay? So, dapat dito ang matira lang x lang or y lamang. No? So, sir, alin ang ititira natin? Again, depending on whichever is more convenient. Kapag pinalitan natin yung x, ang matitira y squared. No? Kapag pinalitan naman natin yung y, ang matitira ay x. But if we replace y, no, i-square pa natin kung ano man yung gagamitin natin na pampalit. No? So, masihirap yon, no? Kasi kung ano yung ipapalit mo, i-square mo pa. So, para madali, ang palitan na lang natin is yung x. So, from here, we will solve for x, which is 21 minus y. No? At itong x na ito, ang ipapalit natin doon para makuha natin yung p as a function of y alone. No? So that p will be equal to 21 minus y, yun yung x, multiplied by y squared. So we now have a function, no, of a single variable y. No? Kung gusto mo, i-distribute mo para maging 21y squared minus y cubed. Now, ano ang domain nito? No? So, remember, this y is a number. No? So, ang pinakamaliit ay di natural, 0. No? Yung y natin. No? And ang pinakamalaki ay di 21. Kapag ito 0, ito sure ako 21. At kapag ito 21, ito naman magzi-0. No? So, the range of values for y, no, is from 0 to 21 alone. So, yan na ngayon yung ating domain. No? Now, actually, kahit hindi naman, kapag nagsasolve ka ng problem, kahit hindi mo i-indicate ang domain, dito lang sinasama ko, of course, for a more complete discussion. Pero kapag nagsasolve ka, kahit hindi mo na siya isama. Okay? So, ano ang next step? After getting a function of one variable, we need to differentiate the function. So, we differentiate this with respect to, of course, y. dp over dy will be, so 21 times 2 is 42. And then may matitira na y. So, 42y minus itong 3, multiply mo sa y, tapos ito magiging y squared. So, magiging 21 times is 42y minus 3y squared. So, that is our first derivative. Okay? 42y minus 3y squared. Now, after getting the first derivative, what do we do? Remember, max-min problem. At the maximum point of the function, the first derivative is always 0. So, i-equate mo ito sa 0. Now, pag na-equate mo sa 0 yan, actually, you can divide both sides by 3y para may matira dyan na 14. Now, or, you can factor. Dahil quadratic ito, mas maganda ipakita natin dalawa yung solutions niya. So, factor na lang natin. Common factor is 3y. 3y times 14, that will give us 42y. And then 3y times y, yun na yung 3y squared mo. No? So, y1, of course, is 0 and y2 is 14. Okay. So, which of these two will give us the maximum product? Of course, it's not 0. Kasi pag ang ginamit mong y ay 0, ay di yung product mo 0, hindi maximum yun. So, obviously, we will use the value y2, which is equal to 14. And that value of y is the value that will maximize the product that we are that we want to maximize. Okay, but we do not want the product. No, we want the numbers. No, so we already obtained one of the numbers. No, 14, and the other number is x, which is 21 minus y. And if y is 14, 21 minus y will be, or 21 minus 14 will be 7. So the other number must be 7. So now we're able to obtain the numbers. The numbers are 7 and 14. No, so if you multiply them, you will get a maximum product. Given that when you add them, the sum that you'll get is 21. Okay? So these are the two numbers whose sum is 21, which when you multiply one by the square of the other will give you a certain maximum product. Okay? Okay, nasa second to the last problem na tayo para sa topic na ito about max-min and optimization problem. So let us now solve problem number 4. Here's the problem. What is the largest possible volume of a right circular cylinder if it is inscribed in a sphere whose radius is 5? So this is another geometric problem for max-min kung saan nag-involve ng shapes. Dito, kinakailangan daw maglagay tayo ng cylinder sa loob ng sphere. So kung sphere ang radius ay 5, ano ang pinakamalaking volume ng cylinder na kasya sa loob niya? So the first step to solve the problem, of course, is to illustrate. Okay? So gawa ka ng illustration. So nasa labas yung sphere, sa loob niya may cylinder. So ang sphere, ang radius ay 5. No? So let us make an illustration. Ito na siya. So yan yung sphere mo, no? Na given ang radius 5 at sa loob niyan dapat mayroong cylinder. Okay? So ito ngayon yung cylinder mo. Tapos ano yung gusto nating i-maximize dito? Gusto nating i-maximize largest possible volume of the cylinder. Okay. So we will maximize the volume of the cylinder. Okay. So now that we have this illustration, what is the next step? Of course, kailangan natin ng label. 'Di ba? Diyan tayo mahilig. Minsan gusto natin may label tayo, no? Kesa naman wala. Sige, lagyan natin ng label, no? Simulan natin dun sa given. Ano bang given? Ang given ay yung radius ng sphere na 5. So ilagay natin 'yan. This is the radius of the sphere which is measured to be 5, no? Tapos, ano pang kailangan ng label? Kailangan natin ng label. Yung dimensions naman ng cylinder. Ano ba ang dimensions ng cylinder para makuha mo ang kanyang volume? 'Di ba kailangan mo ang radius at saka height. So let the radius of the cylinder be simply r and its height be equal to h. So ito na yung radius niya r at ito na yung kanyang height, no? Na h. So ngayon may label na yung ating cylinder. Dahil dyan, makakagawa na tayo ng working equation. No? So, paano nga ulit gumawa ng working equation? Yung quantity na gusto mong i-maximize. Which in our case, for this problem, is the volume of the cylinder. Now, looking at this illustration, no, together with the labels that we put there, ano ang volume ng cylinder? So, try to recall your topic in geometry. Kung nakalimutan nyo, no? Ito, ibibigay ko na. The volume of the cylinder is pi r squared h. Yan. So, as we can see, the volume contains two variables, r and h. And, as a rule, sa ating pagsosolve, we need to express v in terms of only r or h. No? At dahil dyan, kailangan natin ng auxiliary equation. No? So, saan manggagaling yung auxiliary equation natin? Of course, sa drawing din. No? Now, bukod sa volume, ano pang nakikita mo dito sa drawing na ito na pwede nating pagkunan ng equation? No? Yes, that's correct. Ayun no, right triangle, 'di ba? Kagaya nung example natin kanina. So i-isolate natin yung right triangle na 'yan para makita mo ng ayos, no? So ito yung radius at ito kalahati ng height kasi mula lang siya dito hanggang doon. And then ito naman yung given radius ng sphere. So if we apply the Pythagorean theorem, we can get an equation r squared plus the square of this. H squared over 4 is equal to the square of this, which is 25. So, ito na po yung auxiliary equation natin. Now, which we can use to reduce the volume in terms of only one variable. The question is, ano ang matitira dito? R or H? Again, that depends on which is more convenient. Now, dito kasi guys, meron na tayong R squared. Now, at dito, meron na rin tayong R squared. So, mas madali kung ang papalitan mo na lang is yung r squared, no? So, we replace it with, ano ba yung r squared dito? That's 25 minus h squared over 4 and then get the square root. no? So, that's wala na palang square root kasi nga naka-square siya, no? So, that's 25 minus h squared over 4. Ipapalit lang natin dun sa r squared, no? So, ito na yun, pi r squared and then h. Again, saan po nanggaling ito? Ito yung expression mo ng r squared in terms of h na galing sa auxiliary equation. So, we now have a function of v, no? Of h. We now have a v. We have the function v as a function of h alone. So, ano ang next step? Kung gusto mo, i-distribute mo yan para maging 25 pi h minus pi h is cube kasi h times h squared is h cubed over 4. So, pi h cubed over 3. Now, the next step is to get the first derivative, no? So, ang first derivative niyan, dv, of course, with respect to h. dv over dh is, anong derivative nito with respect to h? So, constants ito at ito naman ay variable. So, ang matitira na lang, constant. So, you have 25h minus. So, ito, yung 3, gagawin mong multiplier. So, magiging 3/4 pi. At yung exponent ng h, mamaminusan ng 1. Magiging 2 na lang. So, magiging 3/4 h squared. So, ito na ngayon yung ating first derivative. Oh, by the way, ito pala ang ating domain, no? Sir, paano mo nakuha yung domain? Again, the height cannot be negative. So, we should start with 0. And, of course, this height cannot be greater than the diameter, no? Kaya, ang limits natin ay hanggang 10. 0 hanggang 10 yung ating domain. No? So, dapat yung makukuha nating value ng h, mamaya, dapat ay within this interval. Okay? So, sige. Now, again, kunin na natin ang first derivative. No? That's 25 pi minus 3/4 h squared. And then, after getting the first derivative, of course, we equate it to 0. Why? Kasi nga po, max-min problem ito. At the maximum point of the function, the first derivative is 0. So, after that, we can now solve for h. No? So, this 25 minus 3/4 pi, h squared is equal to 0. If we divide both sides of the equation by pi, makakancel po yung pi natin dito. No? Makakancel ang pi. Tapos, ilipat natin itong part na ito sa kabilang side ng equation para ang makuha mo 25 is equal to 3/4 h squared. Now, so after that, multiply both sides by 4. 25 times 4 is 100. So 100 is equal to 3h squared. And therefore, h squared is 100 over 3. Ayan. So, from that, we can now solve for the value of h, which is square root of 100, which is 10 over square root of 3. So, ngayon, ano na ang saysay at kahulugan ng value ng h na nakuha natin? Again, this is the value of h that will maximize, no, the volume of this cylinder. Now, so kapag ang h na ginamit mo ay 10 over square root of 3, yun ang magbibigay sa iyo ng pinakamalaking volume ng cylinder. So, ang hinahanap dito, largest volume. So, hanapin natin ngayon yung volume. Itong h na ito, which is 10 over square root of 3, substitute mo lang dito. No? Para makuha mo yung Vmax. Okay? So, we substitute pi times 25 minus, ano yung h squared? That's 100 over 3. Divide mo lang ng 4. So, para magiging 3 times 4 yan. So, 100 over 3 times 4, no? And then, may h pa sa labas. Okay, which is 10 over square root of 3. Okay, so ngayon, simplify lang natin ito. Makukuha mo na yung volume, no? That's now the maximum volume of this cylinder. Okay, so pag itong term na ito na nasa loob ng parenthesis, simplify mo, that's 25 minus 100 over 12, no? Kung na mental math mo, edi ikaw na yung magaling, no? Pag kumuha ka ng calculus, makuha mo dyan, wait, that's 50 over 3. No? So, 100 or pi times 50 over 3 times 10 over square root of 3. So, 50 times 10 is 100. 50 times 10 is 500 rather. So, makakaroon ka ng term na 500 times pi over square root of 3. Okay? So, now, that is the maximum volume of the cylinder inside. Okay? So, we have 500 pi over 3 square root of 3. So again, kung nahihirapan ka mag-mental, i-calculate mo na lang ito at ang makukuha mong sagot ay ganito po, 500 pi over 3 square root of 3. Okay? So, sir, baka naman may shortcut ka dyan, kagaya nung kanina. Actually, meron, no? Shortcut dito is, pansinin mo kunin mo lang ang volume nung sphere. Ano ba ang volume ng sphere? That's 4/3 pi r cube, right? Sulat natin. Pwede ba to? Yes. Pen, that's 4/3 pi r cube, no? At i-divide mo lang yan ng square root of 3. Okay? Ito na ngayon yung shortcut para sa problem na ito. Ito na yung maximum volume ng cylinder sa loob ng sphere. Try nga natin kung tatama, no? So, ang given natin na radius ay 5, no? So, yung 5 na yan, kapag kinube mo, 5 cube is how much? Sorry, 5 cube is 125, no? 125 times 4 is 500, no? So, we have 500 pi, no? Over 3 square root of 3, which is just the same. Okay, so that's the shortcut for this particular problem. Ano? Pag nakita nyo po ang problem na ito, again, ang pinakamalaking volume ng cylinder na kasya sa loob ng sphere ay simply yung volume ng sphere, i-divide mo lang ng square root of 3. Isn't it amazing? Yes. Amazing grace. Okay, now we're down with the fifth and the final sample problem for this lecture video about max, min, and optimization problems. So problem number 5 is about minimizing the time required to reach a certain destination. Okay, so let me present to you the problem. There is a person who is in a boat, and that boat is 3 kilometers from a certain point P on a straight shore. Straight. Eh di kayo na lang kasi kayong straight. Hindi ako sali dyan. Okay. So that point P is on a straight shoreline, and his destination is 5 kilometers directly east of point P. Okay. So let us illustrate the problem. Okay. O sige, tapusin muna natin. If he's able to row 4 kph and then walk 5 kph, how far from his destination must he land on the shore in order to reach the destination in the shortest possible time? So that person is in a boat and he wants to go somewhere along the shore, no? But he will not directly go from the boat to that point, no, by just rowing, no? He will combine rowing and walking. Why? In order to get to his destination in the shortest possible time. Okay? So, first, let us have some illustration for this problem. Now, so here it is mentioned that there is a straight shore. No? And there is a point P on that straight shore. So, first, this is the straight shore, for example. No? Straight shore. No? So, nasa ang dagat? No? So, halimbawa, andito yung dagat at andito yung buhanginan. No? Okay. So, there is a point P on that straight shore. Let this be the point P. Okay. Now, where is the boat? Of course, the boat should be here. Wala ka naman yung bangka na mamangka sa buhangin. No? So, malamang yung bangka nasa dagat. So, kung ito yung dagat, somewhere here. No? So, gaano kalayo yung bangka mula sa point P? 3 kilometers. So, kung walang nabanggit kung saan, that's the shortest, no, distance. No? So, na magagawa natin by drawing a line segment perpendicular to this line para maging shortest. No? So, 3 kilometers yung layo ng bangka mula sa point P. Ayan. Now, sabi niya, the destination is 5 kilometers directly east of P. Okay? So, east is to the right. So, the destination should be somewhere here. No? 5 kilometers to the east, which is to the right. For example, ito yung point D na destination na may layong 5 kilometro mula sa point P. So, this boat wants to get here, no, in the shortest possible time. And because of that, he won't go directly to point P and walk from point P to D. Why? Because if he will be walking from point P to D, he will be walking a quite longer path. No? And because the path is longer, then he might not be able to get to his destination in the least possible time. Now, sir, kung gusto mo, di magbangka na lang siya mula point D hanggang point D. Kasi yun ang shortest distance. Yes, that is the shortest distance. Now, however, mabagal siyang magsagwan. No? 4 kph lang. And because of that, although this is the shortest distance, he might not be able to get to his destination in the shortest possible time because he is relatively slower when it comes to rowing compared to walking. Okay, so what must he do? He needs to land somewhere in between points P and D. So, for example, this is the landing point L. So from here to there, he will row, no? At a rate of 4 kilometers per hour. And then from point L to point D, he'll just walk it at at exactly 5 kph. No? So ito yung path na kanyang sasagwanin, no? Gamit ang bangka. At mula dito, siya naman ay maglalakad hanggang doon. Okay. So gaano kahaba ang kanyang ita-travel by boat? So ito yun, which is the hypotenuse of this right triangle. So the length of this hypotenuse depends on the value we put here. So lagyan muna natin yan ng x. No? So kung ito ay x at ito ay 3, makuha na natin itong hypotenuse using the Pythagorean theorem, right? So using the Pythagorean theorem, this hypotenuse is the square root of 3 squared, which is 9 plus x squared. So we have the square root of 9 plus x squared. Okay, now this is the length of the path that he will travel by boat, and then from point L to point D, he will travel by walking. So how far should he walk? This distance should be 5 minus x. Okay, so that is the length of the path that he will travel by walking. Okay, now the problem is fully represented already. No? So the next step is to formulate the working equation. No? And again, the working equation is the quantity that you want to maximize or minimize. But in this case, we want to shortest possible time. So we want to minimize. What quantity are we going to minimize? Shortest possible time. So we will minimize the time. Okay? But what formula for time should we use? Okay, recall the formula for finding the distance. If you are traveling at a constant speed v, the distance is equal to the speed multiplied by the time. No? If your speed is v, you multiply it by t, you'll get the distance traveled. Okay? But here, we want to get the time because we want to minimize the time. So we will solve for t, that is simply d over v. Okay? But there are two time intervals that we can get here. The time interval from B to L and the time interval from L to D. So we will simply add the two, T1 plus T2. But again, that D or T is equal to D over V. Okay? So for T1, that is B1, this distance, divided by the speed by which he can row, which is 4, plus D2, which is 5 minus x, divided by the rate of walking, which is 5. Okay? So we now have D1 over V1 plus D2 over V2. Substituting, actually nabanggit ko na kanina, ano yung D1? Ito yon, D1 mo. No? Over V1, gaano siya kabilis magsagwan? 4 plus D2, 5 minus x. At gaano siya kabilis maglakad? 5. Okay, so we now have our working equation. At pansinin mo, anong napansin mo sa working equation natin? On the right-hand side, we only have x as our variable. So, hindi mo na kailangan dito ng auxiliary equation. Rekta na yan. No? Anong sunod na step? Yes, you have to differentiate with respect to x. So, we get dt over dx. Okay, isa-isahin natin yung pagkuha ng derivative. So, itong 1/4, multiplier lang yan. Tapos may square root. Di ba yung square root ay something raised to 1/2? Tapos yung something raised to 1/2, pag kinunan mo ng derivative, yung 1/2 magiging multiplier. No? So, magkakaroon ng 1/4 multiplied by 1/2. Okay? Multiplied by 1/2 times, hindi pa tapos, copy-paste yung nasa loob at yung exponent niya, maminusan mo lang ng 1. So, 1/2 minus 1 is negative 1/2. And then, hindi pa rin tapos kasi according to chain rule, you have to differentiate the term inside the square root. No? So, the derivative of 9 is 0 plus the derivative of x squared, which is 2x. So, ayun po. No? So, this is the derivative of the first term. How about the second term? 5 over 5 is 1. The derivative of 1 is 0. And then we have negative x over 5, whose derivative is negative 1/5. Okay. So this is now our derivative, which we can simplify. Ay, pag nag-simplify ka dyan, may makakancel ba? Yes. Makakancel ang 2. Ayan, nag-cancel yung 2 mo. Tapos may matitirang x sa taas. At sa baba, may matitirang 4. Tapos, dahil ito ay negative ang exponent, pwede mo siyang ibaba. At the 1/2, so square root. So, dapat sa denominator, may term na square root nito. Okay? And then, minus 1/5. So, ito na siya ngayon. Okay? So, x sa taas, ito yung natirang x. Ito yung 4 sa baba. At ito, dahil negative ang exponent, binaba natin. Ang exponent is 1/2, which means nasa loob siya ng square root. And then, minus 1/5. Okay? So, yung ilaw ko dito namamatay, naiitim na rin yung mukha ko. Kailangan na nating matapos kasi ang init-init na hair. Okay? So, sige. Anong sunod? Pag nakuha mo yung first derivative, equate to 0. No? So, pag i-equate mo to sa 0, actually, ito pwede mong ilipat sa kabila. No? Tapos, i-multiply mo to at saka iyon. So, makakaroon ka ng 5x is equal to 4 times the square root of 9 plus x squared. Ayan. So, algebra problem na lang ito. Hindi na ako masyadong mag-spend ng masyadong time to solve for x, no? Because I think you can do it as an exercise, no? Solving for x, no? In this expression, we get a value of 4. Okay, so this is now the critical number. Pero ito ba yung required sa problem, no? Have we solved the problem already? Hindi pa. Bakit? Kasi sa problem, ano bang itinatanong? O, tingnan mo. How far from his destination must he land? Okay. So, kung ito yung destination, saan daw dapat siya maglaland mula doon? So, ang nakuha natin ay x, which is basically this. Pero hindi pala yun ang itinatanong. Kasi ang itinatanong, how far from his destination must he land? So, ito yun. Ito ang landing point, and that is 5 minus x from his destination. So, if x is 4, then 5 minus x, no? 5 minus 4 is 1. So, therefore, the answer to this problem is 1 kilometer. No? He should land 1 kilometer from his destination in order to get, no, into that destination in the shortest possible time. Okay? So now, ito na po yung sagot dito sa problem na ito. Na-solve na natin siya. So as a recap, we were able to demonstrate how to solve max, min, and optimization problems using 5 examples that I have already solved. And I hope sa mahigit na 1 oras na pagtsatsagaan nyo sa panonood ng aking video na ito, kayo ay matuto at sa inyong pagpapractice, maging magagaling din kayong mga students. Okay? So, yung mga math skills nyo, konting practice lang. Actually, konting practice hanggang sa dumami yung practice, magiging magaling ka na rin dyan. Okay? So, hanggang dito na lang. Bye for the moment.